Now, let's get a closer look.
Cartilage is an avascular, smooth, and elastic tissue with various forms that allow it to function in a variety of ways. It can act as a smooth surface for bone articulation within joints, play a role in bone formation, and also provide structural support, such as the cartilage rings in the trachea. The majority of the tissue consists of extracellular matrix, or ECM, and only a relatively small number of chondrocyte cells. Mature chondrocytes are responsible for secreting and maintaining the extracellular matrix of the cartilage. Based on the appearance and specific function, cartilage is separated into three main types: hyaline cartilage, elastic cartilage, and fibrocartilage. Hyaline cartilage has a glassy appearance and can be found on many articular surfaces, as well as cartilage that provides structural support. Elastic cartilage contains a dense network of branching elastic fibers that allows it to be more flexible, which is why it's often found in structures that need to be firm yet still flexible. Some examples include the epiglottis, larynx, and the pinna of the external ear. And finally, fibrocartilage contains dense connective tissue with collagen fibers, as well as bands of extracellular matrix. This type of cartilage is found in structures such as the meniscus and intervertebral discs. First, let's focus on hyaline cartilage, which is the most common type of cartilage. This image is an example of hyaline cartilage on the articulating surface of a long bone, with the articulating surface located at the top of the image. The image on the right is a longitudinal section of the trachea, which is an example of hyaline cartilage providing structural support. Both images were stained with hematoxylin and eosin, or H&E for short. With this stain, the cartilage stains a dark purple due to its strong affinity for hematoxylin. If we take a closer look at the tracheohyaline cartilage, it has an outer layer of dense, irregular connective tissue surrounding the cartilage called the perichondrium. The perichondrium is also further separated into an outer fibrous layer and an inner chondrogenic layer. Within the chondrogenic layer, there are spindle-shaped cells that differentiate into small cells called chondroblasts as they migrate deeper into the cartilage matrix. These cells will start producing cartilage matrix and eventually mature into chondrocytes. The chondrocytes are found within small cavities called lacunae that are often arranged in clusters of 2 to 4 cells. The extracellular matrix, with its glassy appearance, is composed of mostly type II collagen and proteoglycan, which is an amorphous gelatinous substance, often referred to as ground substance. Although articular hyaline cartilage is very similar to tracheohyaline cartilage, a key difference between them is that articular cartilage does not have a perichondrium of connective tissue surrounding it. The lack of perichondrium ends up limiting the articular cartilage's ability to grow. Now, elastic cartilage is similar to hyaline cartilage, except the extracellular matrix contains its defining feature of a dense network of elastic fibers, which gives this type of cartilage its flexibility and elastic characteristics. This image from the pinna of the external ear is stained with Mason's trichrome and aldehyde fuchsin. The aldehyde fuchsin stain highlights the elastic fibers dark pink within the matrix of the cartilage. At 32 times magnification, we can see some general features of elastic cartilage that are similar to hyaline cartilage, such as the cartilage matrix, which stains blue, the chondrocytes within the lacunae, and also the perichondrium at the top, which is stained purple and dark blue. The last type of cartilage is fibrocartilage, which has a mixture of features from hyaline cartilage and dense connective tissue. And similar to articular hyaline cartilage, this type of cartilage doesn't have a perichondrium. The general structure of fibrocartilage can be seen even at low magnification, with alternating layers of purple hyaline cartilage matrix and thick layers of dense connective tissue that have type I collagen that stains pink. The fibers are arranged in the same direction as their functional stress to maximize their strength and resist deforming. Zooming into 40 times magnification, we can find chondrocytes within their lacunae in the basophilic matrix, similar to the other types of cartilage. Fibrocartilage also has scattered fibroblasts that are typically within the fibrous region of the tissue. These cells can be identified by their long and thin nuclei, such as the one seen in this image. Alright, as a quick recap, there are 3 main types of cartilage: hyaline cartilage, elastic cartilage, and fibrocartilage. The hyaline cartilage has an extracellular matrix with a glassy appearance and can be found in articulating surfaces of long bones and structures such as the trachea. And the articular hyaline cartilage doesn't have a perichondrium. Elastic cartilage is found in structures such as the pinna of the external ear and the epiglottis. The matrix of elastic cartilage is similar to hyaline cartilage, except it also has a dense network of elastic fibers, and it always has a perichondrium. And finally, fibrocartilage is found in structures like the intervertebral discs and meniscus. The tissue is a combination of hyaline cartilage and dense connective tissue. So, as a result, it contains more type 1 collagen and fibroblasts compared to the other types of cartilage. And, similar to hyaline articular cartilage, it doesn't have a perichondrium.